day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we will be talking about matter and material, which consists of 47 marks. And for today's topic, we will be dealing with organic chemistry. That is question 2, which has plus minus 21 marks. The mark allocation for paper 2 is that you have section A, which consists of 5 multiple choice questions. That has a total of 10 marks. And you also have section B, which consists of structured or long questions. And that has a total of 65 marks. And now the total for paper 2 is 75 marks, with a duration of 1 hour 30 minutes. Then the topics to be covered in paper 2 will be covering under the content will be covering matter and materials, which has a total of 47 marks and a percentage weighting of 62. Then we'll also be covering chemical change, which has a total of 28 marks and a percentage weighting of 38, which will then give us a total of 75 marks. So what you need to know in terms of organic chemistry, you need to know how to, or you need to be able to define organic chemistry. So it says the study of carbon-containing compounds. So by the word carbon, we are talking about the very same carbon that you know that you find on the periodic table. And then it says organic molecules are molecules containing carbon atoms. So it means that in this case, we are speaking about the very same carbon that you know, that is from your periodic table. Then you need to know hydrocarbons. So this is according to the examination guidelines. It says organic compounds containing only carbon atoms and hydrogen atoms. Okay, so organic compounds containing only what? Containing only carbon. So the very same carbon from the periodic table and what? And hydrogen and hydrogen atoms. So those are called your hydrocarbons. Okay. Then the applications of organic chemistry. So we can use organic chemistry in perfumes, medicine. We can also use it in terms of paper, nail polish, candle, fabrics, soap, and gasoline, just to name a few. Then the properties of carbon are that carbon is on group number 4 or group number 14 from the periodic table. So if you are going to count from the periodic table, this is group number 1, group number 2, and then over here we have group number 3, and then this is going to be group number 4. Then we are saying that is where we will find carbon, or if you are going to count from number 1, 2, and this is your 3, your 4, all the way to the right hand side, and then on group number 14, that is where you are going to find carbon on the periodic table. So another thing, it says that carbon has how many bonds? So carbon has 4 bonds. So carbon is on group number 4, and then carbon has how many bonds? It has 4 bonds. So if we are to draw the carbon there, it has how many bonds? Carbon has 4 bonds. Okay. So this will be bond number 1 there, bond number 2, bond number 3, and bond number 4. Then it says carbon forms what? Forms covalent bonding. So what is covalent bonding? It is a bond between what? Between non-metals. Okay. Then it says it is capable of forming what? Multiple bonds. So what do we mean by that? Multiple bonds. So it means that carbon can also be able to form, for example, your double bonds there, or the very same carbon can be able to form what? triple bonds. So it is able to form multiple bonds. So it means that it can be able to form more than one bond. Then it says it is able to bond with the other carbons to form long chains. So this carbon is able to bond with other carbons so that it is able to do what? So that it is able to form what? Long chains. So there is our carbon, the letter C. We find it where? On group 4 or group 14 of the what? Of the periodic table. Then you need to define, according to the examination guidelines, you need to be able to define what? The general formula. It says it gives a general description of the homologous series and then indicates the types of atoms and the ratio of the atoms to one another. Then you need to be able to define the homologous series. So it says a series of organic compounds that can be described by the same general formula and where each member differs from the next with a CH2 group. Then you need to be able to define the functional group. It says an atom or a group of atoms that determine the chemistry of a molecule, or an atom of a group of atoms that determines the physical and the chemical properties of organic compounds. So I am going to explain this further, but you need to be able to define them according to the examination guidelines. So next, you need to know all the homologous series. So we have alkane, we have alkene, alkyne, haloalkanes, alcohols, aldehydes, ketones, carboxylic acid, and esters. Then you need to know the structure for all the homologous series, and then you need to know the name of the functional group. So how are you going to identify the alkanes? You are going to identify the alkanes by what? By the single bonds between the carbon atoms. So it says only CH and carbon what? Single bonds. So you're going to identify it by the single bonds between the carbon atoms. Then how are you going to identify the alkenes? Alkenes have what? They have a double bond. So therefore the name of the functional group is carbon-carbon double bond. The alkynes have a triple bond there. They have a triple bond, so therefore you are going to identify them by what? Carbon-carbon what? Triple bonds. Then the haloalkanes, so wherever you see that X there, it means that you are going to have what? You are going to have one of the halogens. So the F is fluorine, the bromine, and the iodine. Then the alcohols, you are going to identify them by the what? By the OH, and the OH would mean that you have what? You have a hydroxyl group. The aldehydes will then have what? C double bond O and an H at the end of the compound or in the beginning of the compound, and that is when you know that you have what? An aldehyde, and therefore the name of the functional group is the formal group. Then next we have a ketone. So how are you going to know that you have a ketone? That is when you have a C double bond O in between what? In between two carbons. So you have a C double bond O, and on the left you have a carbon, on the right you have a carbon. So therefore you will know that you have a ketone, and we call that a carbonyl group. Then next, with the carboxylic acid, you will have a C double bond O and a what? And an OH, and therefore it will be called a carboxyl group. Then the last one is what? Is an ester, which has C double bond O, and next to it we have another oxygen and a carbon. So that is how you are going to identify the what? The ester. Okay, so let's have a look at this example here. It says consider the table below and identify the homologous series. So we need to identify the homologous series to which the following compounds belong, and give the name of the what? And give the name of the functional group. So right now we are just looking at the structures, and from the structures we need to determine the what? We need to determine the we need to identify the homologous series. Then we need to give the what? We need to give the name of the what? Of the functional group. So let's have a look at the first one. On A, we can see that we have C double bond O, and the C double bond O is between what? Is between the two carbons. So it means that this must be a what? This must be a ketone. So what is the name? So this one, the ketone, it represents what? That is the homologous series. So what is the name of the functional group going to be? The name of the functional group is therefore going to be a carbonyl. Then we move on to the next one, which is the letter B. So on letter B, we can see that we do not have a C double bond O, we do not have double bonds, but we only have what? We only have single bonds. So from that, we can therefore say that this must be a what? This must be an alkane. So in terms of the name of the functional group, it will therefore be what? Carbon-carbon single bonds. So because we can see that we do not have double bonds on this structure, we do not have triple bonds, we do not have an OH or a C double bond O, so it can only be what? Alkane, and therefore carbon-carbon what? Carbon-carbon single bonds. Then we move on to the next one, which is the letter C. So the letter C, what can we observe from here? So firstly, we need to determine the what? The homologous series. So we can see that by the letter C here, what do we have? We have a double bond. And then if we have a double bond, it means that the name will therefore be what? The name will therefore be an alkene. Okay? So if it's an alkene, the name of the functional group will therefore be what? It will be carbon-carbon what? Double bonds. So we start with the alkanes. Alkanes is what? It's carbon-carbon single bonds. Then alkenes, because of the double bond there, it's therefore going to be what? Carbon-carbon double bonds. Then we go on to the letter what? The letter D. So what is it that we can observe on the letter D? On the letter D, we can see that we have what? We have an OH group there. So if we have an OH group, number one, what is the homologous series? So the homologous series is that this is going to be what? An alcohol. And then number two, because we have an OH group, what is the name of the functional group? Because that's the second part of the question. So the name of the functional group will therefore be what? The hydroxyl group there. Okay. Then let's have a look at this activity here. It says, consider the table below and identify the homologous series to which the following compounds belong. Okay. So learners, for this one, I am going to give you 3 minutes. 3 minutes for this activity, and then we can therefore do it together. Welcome back, learner. So if you have any questions, you can send your questions to the following number 063 508 1301. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. Okay, so let us continue. Then it says, consider the table below and identify the homologous series to which the following compounds belong. So again, on this one, what do we have? We have a C double bond O and an H, which is towards the end there. So it means that we have what? We have an aldehyde. Then on letter B, what is it that we have? We can see that we have a double bond. So if we have a double bond, it is therefore going to be represented by what? By an alkene. Then by letter C, what is it that we can see? We can see that we have an OH, and then OH would be represented by what? By an alcohol. Letter D, we have a halogen, which is a bromine there, and the bromine would be represented by what? By a haloalkane. Letter E, we have an OH group there, and the OH group represents what? Alcohol. Letter F, we can see that we have a C double bond O, and the C double bond O is between the two carbons, so therefore this will represent what? This will represent a ketone. So just make sure that you know how to identify the structures, because once you know how to identify the structures, you will later on be able to also understand how to do the IUPAC naming. Then the next activity here says, consider the table below and identify again the homologous series to which the following functional groups belong, and then you also give the name of the functional group. So we want the homologous series, we also want the name of the functional group. So again, on this one, what do we have? We can see that we have a double bond. So therefore, the double bond will mean that we have what? We have an alkene, and the name of the functional group will therefore be carbon-carbon what? Double bond. Then letter B, we can see that we have what? We have single bonds. The single bonds represent what? Alkane. So therefore, for the name of the functional group alkane is what? Carbon-carbon single bonds. Then letter C, what can we see there? The X, remember, it represents what? It can represent the halogens. So therefore, if we have halogens, it will be what? A haloalkane, that's the name, that's the homologous series, and therefore a halogen would be the name of the functional group. Then by letter D, what can we see there? We can see that we have an OH group. So an OH group represents what? Is represented by alcohols, and therefore the name of the functional group is what? Is hydroxyl. Then letter E, what do we have? We have a C double bond O, and it is in between the what? It is in between the two carbon atoms there. So therefore the homologous series would be a ketone, and the name of the functional group would be a carbonyl. So the last one, what can we see there? We have single bonds. So single bonds would be alkane, and then therefore what? Carbon-carbon single bonds. Okay. So from here, you need to know how to define the following general formula. It says it gives a general description of the homologous series, and it indicates the type of atoms and the ratio of atoms to one another. Number 2, this is according to the examination guideline. Number 2, molecular formula, a chemical formula that indicates the type of atoms and the correct number of each in a molecule. Structural formula, it says of a compound shows which atoms are attached to which within the molecule, and then it says atoms are represented by their chemical symbols and lines are used to represent all the bonds that hold the atoms together. So I'm still going to explain them further. Then condensed structural formula, it says this notation shows the way in which the atoms are bonded together in the molecule. So here we have examples of each. So for the general formula, if this represents what? If this represents your general formula, and you are told, for example, that you have 4 carbons. So for you to use this general formula, then you are therefore going to say what? Cn is the number of carbons, so C4H2. So since N is the number of carbons, we said if we have, for example, 4 carbons, that is then going to be 2 multiplied by 4 for this N here, plus by what? Plus by the 2. So therefore you are going to have C4H what? H2 times 4 is 8, plus 2, it will give us a total of what? It will give us a total of 10. So general formula, you are therefore able to use that formula so that you are able to get your what? So that you are able to get your molecular formula. And from the molecular formula, which is what? Which is C4H10, you are then able to draw your what? You are then able to draw your structure. So from the molecular formula, what are we saying? We are saying we have C4H10. That means that we have how many carbons in total? It means that we have 4 carbons in total. So there are your 4 carbons. And it also means that you have how many hydrogens in total? You should have 10 hydrogens in total. So if you count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens. Okay? So this one then is an example of a condensed structural formula. So with the condensed structural formula, then you can construct it using the what? Using the structural formula. So how are you going to do that? So you'll say that, okay, the first part has what? Has 1 carbon. The first part here has 1 carbon. And how many hydrogens? And 3 hydrogens. So it's 1 carbon and 3 hydrogens. So therefore you'll have a CH3. And then the second part now, this one. The second part has how many carbons? It has 1 carbon. And how many hydrogens? And 2 hydrogens. So you write CH2. And then the third part now of the structure, it has what? It has 1 carbon and what? And 2 hydrogens. So therefore it will be CH2. And then the last part now has how many carbons? It has 1 carbon again and what? And the 3 hydrogens. So that is how you will write your condensed structural formula. So again, the first part is made by this one here, CH3. The second part, CH2. The third part, CH2. And the last one is your what? Is your CH3. But then again, from your condensed structural formula, you are also able to use this information and do what? And draw your structure. And again, from the condensed structural formula, you are able to use that information and write your what? Your molecular formula. So if you are using the condensed structural formula, how are you going to write your molecular formula? You are then going to say how many carbons do you have in terms of your condensed structural formula. So we can see that we have how many carbons? We have 4 carbons, so it's C4. And then how many hydrogens do you have now in total? So you write your hydrogen there, and then you can count. So you have 3 plus 2, which is 5, plus by 2 is 7, plus by 3 is what? Is 10. Okay, so from your From your structural formula, you were able to write your condensed structural formula. From the condensed again, you were able to write your molecular formula. And from the general formula, you were able to write your molecular formula. From the molecular, you were able to write your structural formula. And from the structural formula, you were therefore able to write your condensed structural formula. So just make sure that you know, you understand, and you are able to apply all of them when it comes to your examinations there. Then on the following example here, it says indicate whether the following organic compounds given are molecular structural or condensed structural formula. Okay, so we can just have a look there. On this one, what do we have? We can see that we have carbon, 3 hydrogens, carbon, 3 hydrogens, carbon, and the 3 hydrogens there. So this would mean that we have what? For the first one, we have the structural formula, and then the second one, we can see that it is not in a structural form, and again, it does not show us the actual. It does not show us the actual combination of the carbon, the actual combination of the carbon and the hydrogens. So we cannot see that, okay, on position number 1, for example, we'll have a CH3, on position number 2, we'll have a CH2. We are not able to see that clearly. So therefore, this would mean that it represents a molecular formula. And then on carbon number, on the letter C, we can therefore be able to see the distribution of how we are going to draw the structure. So therefore, it would mean that carbon number C would be represented by by the condensed structural formula. Then let's have a look at this one. Indicate whether the following organic compounds given again are molecular structural or condensed structural formula for the organic compounds. So on the first one, we have a structure. So therefore, the letter A will be represented by by a structural formula. Then on letter B there, we can see that it shows us the totals now to say, okay, the total number of carbons is is 3, total number of hydrogens is 7, and then therefore we only have 1 chlorine. So that would mean that it is our molecular formula. And then by letter C now, it shows that, okay, on carbon number 1 we'll have C and how many hydrogens? 3 hydrogens. On carbon number 2 we have 2 hydrogens. So therefore this one will represent sorry about that, Lena. So this will be a condensed instead, condensed condensed structural formula. Then on letter D, we can see that we have a structure. So therefore it would be a structural formula. Then hydrocarbons, it says are organic compounds containing only carbon atoms and hydrogen atoms. So they are organic compounds containing only carbon atoms and and hydrogen atoms. Okay, so the first one, it says we have single bonds between the carbon atoms. So we can see that between this carbon and this carbon, there's only a single bond. This one and this one, single bonds. This one and this one, we can see that we have single bonds. Then the second one, it says a double bond between a double bond between the carbon atoms. So we can see that, for example, between this one and this one, there's only 1 line, so it shows that it's a single bond. This one and this one, it's a single bond, and then between this one and this one we have a double bonds. Then it says a triple bond between a triple bond between the carbon atoms. So we can see that between this carbon and this carbon, single bonds, this carbon and this carbon, single bonds. And then therefore on this one we have what? We have triple bonds. So this one we have what? Double bonds, and then on this one we can only see that we have what? We have single bonds. Then it says saturated what? Saturated hydrocarbons. Saturated hydrocarbons contain only what? Only single covalent bonds between the carbon atoms. And then the homologous series, we spoke about that. We said in terms of the homologous series, this would represent what? This would represent the alkanes. And then those alkanes, as you can see in between the carbon atoms, what do we see there? We can see that we have what? We have single bonds. Then unsaturated hydrocarbons, compounds contain covalent double or triple bonds between the carbon atoms. And what is an example of the homologous series? It is the alkenes. So again, between this one and this one, what do we see there? Single bonds. But between this carbon and this carbon, what can we see there? We can see that we have what? Covalent double or what? Or triple bonds. And then again, between this one and this one, what do we have there? We have single bonds. Again, between this one and this one, single bonds. This one and this one, single. This one and this one, it's single bonds. And between these two carbons, we can see that we have a what? We have a double bond. And then the other one is again unsaturated hydrocarbon, compounds that contain covalent double or triple bonds between the carbon atoms. So the homologous series would be what? Would be alkynes. And then again, between this carbon and this carbon, single bonds, this one and this one, single. And then between these two carbons, what do we see there? We see that we have a triple bond. Then again, between this one and this one, it's single bonds. This one and this one, single bonds. This one and this one, it's single bonds. And between these two, what can we see there? We can see that we have what? A triple bond. So in terms of the unsaturated hydrocarbons, an example would be what? It would be alkenes. Alkenes which have what? Double bonds. And then again, unsaturated hydrocarbons, an example would be what? Would be alkynes which have what? A triple bonds. And then an example of saturated hydrocarbons would be what? Would be alkanes now, which have what? Which have a single bond. So it's what? It's alkanes which have a single bond, alkenes which have a double bond, and alkynes which have what? A triple bond. So the alkane, we are saying the alkane is what? Is the saturated hydrocarbon. And then we are saying this too. So the alkene and the alkynes, they have what? So the alkenes they are unsaturated. Why? Because they have double bonds. And then we are saying that the alkynes are unsaturated. Why? Because they have what? They have triple bonds. Okay, then the example here says identify the following compound as saturated or unsaturated and give a reason for your answer. Okay, so we just spoke about it now. You just need to observe. So between this one and this one, what can we see? We can see that we have a single bond, this one and this one. We have single bonds. And then between this one and this one, single bonds. But between these two, we have what? We have double bonds. So therefore, it would mean that it is what? It is unsaturated. And then your reason would therefore be what? The compound contains what? Double bonds between the carbon atoms. So as we can see here, it contains double bonds. So therefore, it is going to be what? Unsaturated. Okay. Let me just give you a minute. I will just give you a minute for you to do this activity, and then we can continue from there. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. So if you have any questions, you can send your questions to the following WhatsApp number 063 508 1301. Okay, so let us go back to the question. It said that you must identify the following compound as saturated or unsaturated, and then you must also give a reason for your answer. So again, we're going to have to look in between the two carbons. So for this one, what do we have? Single bonds there, and then between this one and this one, single bonds again. But between the last two carbons, we can see that we have what? We have a double bond. So therefore, our answer would be what? Would be unsaturated. And what is your reason? The compound contains what? Double bonds between the carbon atoms. So as we have said, if it contains what? Double bonds, or if it contains triple bonds, therefore we would classify it as what? As unsaturated. But if it contains what? The single bonds, then we would classify it as what? As saturated. Okay, so looking at this one, again, you'll have to identify between this one and this one, what can you see there? It's single bonds. Between this one and this one, again, it's the single bonds, and this one and this one again is the single bonds. So therefore, how would we classify this one? We would classify this one as what? As saturated. Why? Because it says contain only single covalent bonds between the carbon atoms. Okay. Then you have to know the table of the homologous series. So for this table, you need to make sure that you know the alkanes, alkenes, alkynes, the haloalkanes or the alkyl halides, and the what? And the alcohols. And then you need to make sure that for each of the homologous series, then you need to make sure that you know the formulas. So the formula for alkane is what? CnH2n plus 2. For alkenes, it's CnH2n. For alkynes is what? CnH2n minus 2. For haloalkanes, it's CnH2n plus 1, and the what? And the X there, which would be representing the halogen. And then for the alcohols, you need to know that it's CnH2n plus 1, and then the what? And the OH group there. Then again, for all of the homologous series, you need to know the structure for each. And then you need to know the what? The name. So this one represents the name of the what? The name of the functional group. And then we will go into naming later. But for each, again, you need to know how to do the naming for each. And then you need to know how to write the what? The structural formula for all of the homologous series. Then you also need to know the aldehydes, ketones, carboxylic acids, and esters. The general formula for aldehydes, which is the same as that one of the ketones, CnH2NO, and the general formula for carboxylic acids and esters, which are the same as and it's CnH2NO2. Then again, for aldehydes, you need to know how to identify the structure. So when you see a C double bond OH, then you know that you are dealing with an aldehyde. Then you need to know the structures of ketones, carboxylic acids, esters. Then the name, this is the name of the what? The name of the functional group. And then this would represent the names of the compounds, and this would then represent the structures of which we are going to be doing later on. Then important to know again, so you need to know all the 9 homologous series, and then for each you need to know the general formula. For each you need to be able to know the structure of the functional group and identify them, and then you need to know the name of the functional group. Okay, so this is just a summary of what you need to know in terms of the table that we just discussed now. Then the IUPAC naming, it says the name of each organic molecule has 3 parts. So number 1, we have a prefix, which is the type and the position of the substituents. Okay, so prefix, it is the type and the position of the substituent. Then we have the parent, which is the number of carbon atoms in the longest chain. Then we have the suffix, which is the type of functional group. So the type of functional group or the homologous series. So again, the homologous series are alkanes, alkenes, alkynes, alcohols, aldehydes, ketones, carboxylic acids. We also have haloalkanes and esters. Then for each you will need to know the suffix. The suffix represents it represents the name ending. So from the alkanes, what do the alkanes end with? So we can see from the name, alkanes ends with the ane, and then alkenes ends with the with the in, alkynes ends with the ein, and then alcohols, they end with the ol. Aldehydes, they end with the al. So maybe you can take it from this side here of the name. And then the ketones, they end with a 1 or an on. And then the carboxylic acids, they end with the with the oic, plus by plus by the acid. And then the esters, we will discuss them later on in detail there. So the number, it says here on the table, the number of carbon atoms. So if you have 1 carbon, then the parent chain would start with a meth. If you have 2 carbons, it would start with the eth. If you have 3 carbons, it would start with the prop. 4 carbons, it would start with the bute. 5 would start with the pent, and if you had 6 carbons, you would therefore be starting with the with the hex. So we are only going to go up to a maximum of of 6 carbons. So that is why we are ending with that is why we are ending with hex. So you need to make sure that you know all of them, all 6 of them. We said if we have 1 carbon, it's meth. 2 carbons, it's eth. 3, it's prop, and if it's 4 carbons, it's bute. 5 carbons, it's pent, and if it's 6 carbons, then you'll have what? You'll have a hex. Okay, so for the IUPAC naming, these are the rules. So you need to determine the functional group, in the structure of the given compound or the homologous series to which the compound belongs. So we have just spoken about, we just did an activity on determining the what? The homologous series. And then we also did an activity on the what? On the identifying the functional groups and also giving the what? Giving the name of the functional group. So before you can do anything in terms of naming, you need to determine the what? You need to determine the functional group, or you need to determine the what? You need to determine the homologous series. So it means that if you do not know the homologous series, or if you do not know the functional group, then you will not be able to give the compound a name. Number 2 says the functional group will determine the what? The suffix, or the last part of the name. So remember, we spoke about the suffix, and then we said the suffix is the what? Is the name ending. Remember, we said if we have, for example, if we have what? Alkanes, we said the name ending would be what? Would be that "ane." And then remember, we said if we have alkenes, the name ending would be what? Would be "in." So it says here that the functional group determines the suffix. So it determines the what? The name ending. So even the what? Even the homologous series will help you to determine the what? The name ending. Because once you are able to say or identify that, okay, I have what? I have an alkane, then you will know that the name ending should be what? Should be "a." If you know that I have, for example, an aldehyde, then you will know that the name ending should be what? Should be "al." And then if you know that you have what? A ketone, then you know that your name ending should be what? Should be "on" or "one." Number 3, it says you count the number of carbon atoms in the longest chain containing the what? Containing the functional group. Okay, so if you are given whatever number of carbons there, then you start counting to say, okay, this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So you count the number of carbon atoms in the what? In the longest chain containing the what? Containing the functional group. Number 4, the number of carbon atoms in the longest chain that contains the functional group will therefore determine the what? It will determine the parent's name. So that now if you say that, okay, I now have how many carbons? I have 4 carbons. So it therefore means that your name should start with the what? It should start with the but. Because remember, we said that if it's 4 carbons, then it's going to start with the what? With a but. If you only have 1 carbon, then you're going to start with the what? With a meth. Okay. Then it says alkane and haloalkanes, number from the side that will give the substituents the what? The smallest number. So for example, if you now have that, and at chlorine, or maybe let me just say hydrogen on this one and a chlorine on this one. So hydrogen, and hydrogen here at the top. So this one, it says if you have alkanes and if you have what? Haloalkanes. So in this case, this one would represent what? It would represent a haloalkane. Why? Because we can see that we have a what? We have a chlorine. It says you number from the side that will give the substituents the what? The smallest number. So we can see that, okay, if I'm to count from my left hand side, this would be carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So if I start counting from the left hand side, carbon number 1, number 2, and number 3, so it means that it is giving my substituent, which is chlorine in this case, it is going to give it position number what? Position number 3. But then if I count from the right and then I go to the left, so this one would be my carbon number 1, number 2, number 3, and carbon number 4. So it means that my chlorine now would be on position number what? On position number 2. So again, going back, it says you number from the side that will give the substituents the what? The smallest number. So now if you think about it, if you can't count from the left going to the right, your substituent, which is what? Which is chlorine in this case, is having what? The number 3. But then if you count from the right and then you go to the left, your substituent, which is chlorine, is now going to have the what? The number 2. So which side would be the correct side according to this statement? It means that you need to count from where? From the right to the what? To the left, so that your substituent will therefore have what? It will therefore have the smallest number. So why are we saying this is the smallest number? 3 is bigger than what? Is bigger than the 2. So again, the correct side for you to start counting would be from the right to the left, because it's giving your substituent, which is chlorine, the smallest what? The smallest number. Okay, and then number 6 there says alkene, alkyne, alcohols, and what? And ketones. So with this 4, number from the side that will give the functional group the smallest side or the smallest number, and then it says the functional group receives a name that is written between the parent's name and the what? And the suffix ending. Okay, so the same goes for this one. So if we have an alkene has what? Has a double bond in between there. So we have your hydrogens there, hydrogens, and then we'll only have 2 hydrogens. So we'll only have 2 hydrogens on, one hydrogen on carbon number 2 and one hydrogen on carbon number 3. So as an example, it says you number from the side that will give the functional group there, the smallest side or the smallest number. So as an example, if this is your alkene, the alkene has what? The alkene has a double bond. If you are to start numbering, if you are going to start counting from the right hand side, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, and then carbon number 5, you will see that your double bond will be on position number what? So if you are counting from the right to the left, I'm saying that your double bond will be on carbon number what? On carbon number 2. But if it's going to be on carbon number number 3. So from the right to the left, so it's 1, 2, 3. But then if you are going to count from the left, so from the left is 1, 2, 3, 4, and 5. If you are going to start counting from the left hand side and then you go away, you go to your right hand side, then I'm saying your double bond will be on carbon number what? Will be on carbon number 2. So for you to be able to use this rule, then we are saying that you need to number from the side that will give the functional group. Functional group in this case is represented by what? By the double bond, the smallest what? The smallest number. So it means that your correct numbering would be from which side? It would be from the left hand side to the what? To the right hand side. Why? Because we can see that if we are counting from the left to the right, the double bond is on position number what? Number 2. But then if we count from the right going to the left, then we can see that the double bond is on position number what? Is on position number 3. So again, we are saying the correct numbering would be from the left to the right and not from the from the right to the left. Then the second part says the functional group receives a name that is written between the parent's name and the suffix ending. So for example, if this was an alkane, we would therefore call it what? A pentane. Okay, but now remember, what are we dealing with now? Now, because it's a double bond, then it is what? It is an alkene. So if it is an alkene, number one, we can see that we have a total of how many carbons? We have 5 carbons. That is why it is a pent. And then the suffix ending, it is not an alkane, but it is what? An alkene. So therefore, the suffix ending should be what? Should be in. Because remember, from alkenes, we said that it ends with the what? With the in. So instead of you having A and E, you are therefore going to have what? You are therefore going to have E and E. That is your pentene. But then the statement here says the functional group receives the name that is written between what? Between the parent name and the what? And the suffix ending. Okay, so we are therefore saying that the parent would be given by what? By that pent. And then to show the position now of the functional group, what are you going to do? It will be pent dash to what? To dash in, because it says what? The functional group receives a name that is written between the what? Between the parent. So we need to give it a position and the what? And the suffix ending, of which in this case it's in. Why? Because we said the in represents what? It represents the alkenes. Number 7 then is aldehydes and what? And carboxylic acids. So it says number from the carbon atom that forms part of the functional group. So aldehydes, remember, is what? Is C double bond O and H. And then remember the carboxylic acids are represented by what? C double bond O, the O and the what? So this is your carboxylic acid, C double bond O, the O and the OH. So it says you number from the carbon atom that is forming part of the functional group. So as an example, if this is your aldehyde, so if this is your aldehyde, how do you know that it's an aldehyde? Because we can see that we have what? We have a C double bond O and the what? And the OH. So it says that you need to number from the carbon atom. So this is the carbon atom that forms part of the functional group. So it means that when you number these aldehydes, you are going to start counting from the structure that is forming the what? The aldehyde. What is that structure that is forming the aldehyde? The aldehyde is formed by the C double bond O and the H. So it means that when you number them, this will be carbon number 1, this will be carbon number 2, and then that will be carbon number 3. So the same goes for your carboxylic acids. Carboxylic acids, what do they have? They have C double bond O and what? And the OH. So it means that whenever you are numbering the carboxylic acids, where are you going to start counting? You are going to start counting from the structure or from the carbon that is responsible for what? For forming that carboxylic acid, or from the carbon that is carrying the C double bond, that is carrying the double bond O and and the OH. So that would be representing your carbon number. That would be representing your carbon number 1. So you do whatever that you do for the aldehydes in terms of numbering. I am repeating, you will have to do for the what? For the carboxylic acids. Okay, number 8, identify the substituents on the parent chain. Okay, so we spoke about that. We said your substituents. On the other example, we said it could be your what? Your chlorine. And then we'll talk about the others later. Then number 9 says use numbers on the parent chain to indicate the position of the substituents on the what? On the parent chain. So again, whenever you do IUPAC naming, you need to give what? You need to give the numbers. Okay. So like we did on the previous example, we said, let's say that you now have that. Let's say you now have this kind of a structure. So it says use numbers on the parent chain to indicate the position of the substituents on the what? On the parent chain. So this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. But remember, we said that whenever we do our counting, what will take priority? It is the chlorine. So this would be carbon number 1, number 2, number 3, and carbon number 4. So we need to give, or we need to write the what? The numbers. We need to count, and we also need to indicate the position of the what? Of the substituents. So in this case, the chlorine would be represented on carbon number what? On carbon number 2. Then number 10 says if 2 or more of the same substituents occur, you must use a dye. For example, if you are going to have 2 methyls on 1 carbon, then you are not just going to name it what? A methyl, but you will have to use the word dye, so that you indicate that you have more than 1 methyl. But the dye would actually mean that you have how many of the methyls? You have 2 of the methyls. Then it says dye is ignored when arranging the substituents in what? In alphabetical order. So this one again, I will explain it further. And then number 11 says when there are 2 or more identical groups on the same carbon, the number of carbon is repeated with what? With commas between the number. So just like we said on the other one, if we have 2 methyls on 1 carbon, so if we have 2 methyl groups there on 1 carbon, 2 methyl groups there on 1 carbon, so the methyl is represented by what? The methyl is represented by a CH what? By a CH3. So as an example, if we have 2 CH3s, that's CH3, and again we have CH3. For example, if we have those 2 CH3s, it says when there are 2 or more identical groups. So identical, we have a CH3 at the top there and a CH3 at the bottom, and then on the same what? On the same carbon, the number of carbon atom is repeated with what? With commas between the number. So we can see that we have what? We have 2 methyl groups. So there is your methyl. And then how many of the methyls do we have there? We can see that we have 2 methyls. So because it's 2 methyls, therefore it will be a di, and then to indicate again the position. So if this is carbon number 1 and this is carbon number 2, so we are therefore saying that on position number 2 we will have a 2 comma what, a 2 comma 2 di what, dimethyl. Okay, and then we are going to do this activity whereby we give the IUPAC names of the following compounds. But before we do the activities, let us take a 3 minutes break, and then we can be able to do the activities together from there. So let us take a 3 minutes. Any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So letter A said that you need to give the name of the what? So for all of them, you need to give the IUPAC names. So where do we start? We can see that we have a C double bond what? C double bond O. So the C double bond O would be representing what? So we start there. The C double bond O represents a ketone. So from there, we can therefore start with the what? With the numbering. So numbering, if we number from the left, let's see, it will be 1, 2, and what? And 3. And then if we number from the right, again, this is carbon number 1, carbon number 2, and what? And carbon number 3. So we can see that if we are numbering from the right to left or from the left to the right, we can see that it does not affect the position of the what? The position of the functional group there. So the position is always on carbon number 2. So it means that we can number from any side. Okay. So the next thing is we need to know the name ending. It's a ketone. So because it's a ketone, then it means that it's going to end with a what? With a 1 or with an on. And then the next thing is that we need to know the number of carbons. So for letter A, if it was an alkane, then letter A would be what? Would be a propane. Okay? But because it's a ketone, then letter A would be, instead of the ane, then we are going to use what? Propanone. Okay? But then remember, we need to indicate the what? We need to indicate the position. And then we said the position will be in between the parent and the what? And the suffix ending. Okay? So it means that we are therefore going to say that we have a prop, and then a prop on position number what? On position number 2. What do we have? We have a C double bond O, which represents a ketone. So position number 2, remember we need to indicate the position. So it's prop dash 2 dash what? Dash on or dash 1 there. So remember, in between what? In between a letter and a number, we'll have a dash there. Between a number and between a letter and a number, we'll also have a dash again. So therefore, our name would be what? Would be prop dash 2 dash what? Dash on. Okay. Again, just to repeat, we said we are going to start by what? By the homologous series. So you need to know, how do you see the homologous series? We can see that we have a C double bond O, and it's in between the 2 carbons. So because of that, we then concluded that it's going to be what? A ketone. So from there, we then said, okay, let us count the number of what? Let us count the number of carbons. So we said that it would not matter whether we are going to count from the left to right or right to left, because we can see that the functional group has the same position or the same number, which is what? Which is the number 2. So from there, we said in counting, we can see that we have a total of what? Of 3 carbons. So if it's 3 carbons, if we said if it was an alkane, we would say it's a propane. But because it is a ketone, we said let us change the name ending to what? To on or to 1. Then from there we said, okay, we are going to separate the what? We are going to separate the parent and the suffix ending. So when we separate, there is the prop, and then on position number 2, we said we have a C double bond O, and then the suffix ending would be represented by what? By the on there, or the 1. Then we go on to the next one, which is the letter what? The letter B. So we can see that on letter B, what is it that we can observe? We can see that there's no C double bond O, there's no OH, there's no chlorine, there's no bromine. So the only thing that we can see is what is happening between this one and this one. We can see that we have what? We have double bonds, this carbon and this carbon, double bonds, this one and this one. We can see that we have what? We have single bonds. So between all the carbons, we have what? We have single bonds. So if we have single bonds, therefore the homologous series, remember we start there, we are therefore going to say that the homologous series is what? Is it? Alkane. Okay, so if it is an alkane, then the next thing is what? Is the name ending. So if it's an alkane, the name would therefore be ending with what? With the ane. So if it ends with the ane, then we are saying the next thing is, okay, let us now count the number of carbons that we have. So we have 1, we have 2, we have 3, and then we have what? We have 4 carbons. So does it matter which side we count from? Let's see. We have 1, we have 2, we have 3, and we have what? 4 carbons. So in this case again, with this compound, it does not matter whether you count from the left to the right or from the right to the left. You are still going to have exactly the same exactly the same name. So after counting, we now see that, so for letter B, we now see that we have what? We have a total of what? Of 4 carbons, okay? So from the 4 carbons, we can now be able to write the name or the IUPAC name of the compound. So the IUPAC name would be what? We said but to indicate the number of carbons, so 4 carbons, and then the aim would therefore be representing the what? Would therefore be representing the name ending. So again, we have a total of 4 carbons, so the number 4 is represented by what? By but, and then the name ending, where does it come from? We said the homologous series is what? Is alkane, so therefore the name ending would be represented by the ane, and hence that's why the full name is what? Is a butane, okay? Then the letter C. On the letter C, again, we need to identify the what? The homologous series. So how are we going to see the homologous series? Again, we check between this carbon and this carbon, it's single bonds. Between this one and this one, it's single bonds. But then between this one and this one, what can we see there? We can see that we have what? We have double bonds, okay? So if we have double bonds, what is the name of the homologous series? Then we know that the name of the homologous series is what? Is alkene. Okay, so if it is an alkene, then we need to identify or determine the what? The name ending, or the suffix or the name ending. So the name ending would be what? Would be a in, right? Then we move on to say, okay, if this was an alkane, our name would just be butane. But if because this is now an alkene, our name is now what? Butene. So you are just removing this ane, you are replacing it with what? With the in. And then from there, you remember that with alkenes, you will have to write the position of the double bonds where in between the parent and the suffix ending. So it means that in order for you to write the position of the double bond, then you will need to do what? You will need to count. So it is, if we can start counting from the left, it's 1, 2, 3, and what? And 4. And then from the right to left is 1, 2, 3, 4. So the number 4 tells us that this is a what? This is a but. And then the in is coming from where? From the name ending, because we said alkenes, the suffix ending is what? Is in. And then we are therefore saying, in terms of counting now, where are we going to start counting? So remember, we need to give the what? The functional group the lowest what? The lowest number. So we can check that if we start counting from the left to the right, the double bond is going to be on position number what? So from the left to the right, it is carbon number 1 there, number 2, and number 3. So on carbon number 3, that is where we have a double bond. So I'm just going to write it there. So if we start counting from the left to the right, we'll have a double bond on carbon number 3. But then if we start counting from the right to the left, then we are saying that where are we going to have the double bond? We are going to have the double bond on carbon number 1. So remember, we need to give this functional group the lowest number. So let's check now, where do we have the lowest number? Do we have the lowest number if we count from the left to the right or from the right to the left? So we can see that we have the lowest number if we are going to start counting from where? From the right going to where? Going to the left. So therefore we are going to separate these two to become what? It will be but dash, position number 1 dash, we have what? We have a in. So but we are saying we have a total of 4 carbons. On position number 1, we are saying that is where we have the double bond, and then the in, we are saying that is our suffix ending. Okay, so now letter D again, we need to identify the what? We need to identify the homologous series. So what is our homologous series there? We see that we have what? We have an OH. So if we have an OH, then this would represent what? The alcohols, and if this is the alcohol, we know that the name ending for the alcohol would be what? Would be all. And then we need to start counting. So what is going to take priority in terms of counting? We are going to start by the OH group. So this is carbon number 1, carbon number 2, and carbon number 3. Or again, we can have carbon number 1, same position, carbon number 2, and carbon number what? Carbon number 3 going down. But remember, you cannot count from the left to the right. Why? Because the OH group must take what? Must take priority. So we can then decide, if we decide on this one, on the straight carbon chain, then this is carbon number 1, carbon number 2, and carbon number 3. And then therefore, the CH3 is going to be acting as your what? It's going to be acting as your branch. Okay, so now let us have a look. We said the homologous series is what? Is alcohol. Why? Because we said we can see that we have an OH group. Then from there we said we will start counting from the carbon carrying the OH group, because the OH group is the one that takes priority. And then from there we now need to determine the numbers of what? Of the substituents. Okay, so on carbon number 2, what can we see? We see that we have a CH3, which represents a what? Which represents a methyl group. Okay, so we are therefore going to write the name as what? As a 2 dash what? 2 dash methyl. Why? Because we are saying that on carbon number 2 we have a branch, and that branch is methyl. Why? Because it only has what? 1 carbon. Okay, so again, if this was an alkane, it would be because it's 3 carbons, a total of 3 carbons, then it was going to be what? A propane. But because this is an alcohol, so it would be propanol. So you are replacing the E with the what? With the ol. Okay, so how would you then do a combination of the name? So for the combination, you are going to have the branch. So the position of the branch, I will continue here. So the position of the branch, we said it's 2 dash what? 2 dash methyl. And then now you need to combine the position of the branch and the parent and the suffix ending. So the parent, we said is going to be what? It's going to be propane, and then to indicate the position of the alcohol. So the alcohol is on position number what? Is on position 1. So therefore propane dash 1 dash what? Dash ol. So because remember we said that for the alcohols again, we are going to be separating the what? We are going to be separating the parent and the what? And the suffix ending. So that is how we would name a compound what? A compound D. So again, this is the what? The substituent. This is the parent. This is the position of the OH group, and then the ol represents the what? Represents the the homologous series there. Then on this activity it says you must give the IUPAC names of the following again. So for letter A, firstly you need to determine the homologous series. So what is the homologous series of this one? We can see that between this carbon and this carbon, single bonds. This one and this one, single bonds. This one and this one, single bonds. And between this one and this one, we have single bonds. So therefore, we are therefore going to conclude that this is a what? This is an alkane. Then number 2, we can then talk about the numbers. So in terms of the numbers, then position carbon number 1, number 2, number 3, and carbon number 4. Or you can go carbon number 1, number 2, number 3, and 4. Again, you can start counting from this one, carbon number 1, number 2, number 3, or carbon number 4. But when it comes to this one, what is going to take priority? What is going to take priority will be this methyl group here. So because it takes priority, it means that when you do your numbering, you need to number from the side that is closest to the methyl group. So it means that the correct numbering would then be what? The correct numbering would therefore be from the left-hand side going to the what? Going to the right-hand side. So it would mean that you would use this one, carbon number 1, number 2, number 3, and number 4. Why? We said so that the methyl group receives the what? The smallest number. Then again, you count the total number of carbons, excluding the substituent. So therefore, you will see that you have a total of what? You have a total of 4 carbons. So because it's 4 carbons, the name would be what? A butane. And then the name ending, it's an alkane. What is the name ending of alkanes? It's ane. And then you need to indicate the what? You need to indicate the position of the methyl group. So on position number 2, we have a 2. So this is for letter A. On position number 2, we have a 2 dash what? Methyl. And then now you need to combine the substituents and the what? And the parent and the suffix. So therefore it would be 2 dash methyl, because on position number 2 we have a methyl there, and what? And a butane. Okay, so we move on to the next one, which is the letter B. The letter B, we can see that we have a C double bond O, and the C double bond O is between the 2 carbons. So this would be a what? This would be a ketone. Then again, we said what? When you do your numbering, you count from the number that is closest to the functional group. So right now, what is taking priority? What is going to take priority right now is going to be your what? It's going to be your ketone. So by letter B, we have a substituent there, and that substituent is on position number 3. So 3 dash what? Methyl. Okay. Then on position number 2, we have a what? We have a ketone. But how many carbons do we have in total? We have 5 carbons. Okay. So if it was an alkane, then we would call it a what? We would call it a pentane. But because it's a ketone, we are therefore going to call it a pentanone. So instead of the ane, you'd have the on or the 1. And then now you must do a combination of the substituent and the what? And the parent and the suffix. So we have a 3 dash methyl, because on position number 3 we have a methyl. And then the carbon chain is made by what? By the 5 carbons. So therefore it's 3 dash methyl pent, okay, for the parent. And then on position number 2, what do we have? We have a C double bond O, which represents a ketone. So therefore we'll say pentane. sorry about that, learners. Let me just fix this one. So this one will be pentane, and then this one would therefore be pentanone. So 3-pentane dash what? Dash on. Okay, and then the last one, the letter C, again, carbon number 1, number 2, number 3, and carbon number what? And carbon number 5. So we can see that on this one, we do not have what? On this one, we do not have any substituents. So therefore, what are we going to do here? We just count the number of carbons. So again, for letter C, we are saying that if it was an alkane, therefore we are going to call it what? A pentane. But because it is a ketone, we are therefore going to call it pentanone. And then we said that we need to indicate the what? We need to indicate the position. So again, the C double bond O is in between what? Is in between the two carbons. So therefore it will be pentane dash on position number 2 dash what? Dash on. So that is how you would do your the IUPAC naming for all your compounds. Okay, learners, so I'm going to leave you with the words of Nelson Mandela, which says that it is in your hands to create a better world for all who live in it. So thank you very much, learners. I will see you next time and at the very same place. Thank you. See you next time, and bye for now.